Welcome to the Skilltorch Disrupt Podcast, where we dive into the world of innovation and technology. My name is Melica, and I am the founder and CEO of Skilltorch, which is a recruitment company operating in the artificial intelligence space. Today, I have with me Mitchell Goldman, who is the Chief Operating Officer at Edgify. He's here to talk to us a bit more about data in the real world in the 21st century and how it is perceived as sort of like the new oil. So, Mitchell, great to have you on here.
Thank you for having me. Good to be here.
Tell me a bit more about yourself and tell me a bit more about your journey in your company and what you're about.
Absolutely. So yes, my name is Mitchell Goldman, currently Chief Operating Officer at Edgify. So within my remit is typically finance, funding, people, partnerships, growth. Really, I kind of look after the scaling side of the business, the 1 to 100, as it were. My background is, I started off as a racing driver as a child, as a teenager. Yes, so that was many former lives ago, or many cat lives ago, as it were. And then moved into actually my first stint as an entrepreneur when I was 16, building an event management business, which we actually exited when I was 20, to quintessentially. I think I lost track in life and ended up in the investment banking world, where I worked at the world's favorites, quote unquote, of Goldman Sachs, JP Morgan, and Barclays Capital. But all jokes aside, I actually really enjoyed it. I worked in the solutions group, so it was very much a sort of problem solving 101. We kind of had a black ops mandate to work across all sorts of different asset classes. So I gained a lot of exposure from the largest companies in the world to the smallest, which I think primed me well to move into the startup world. So I moved away from IB and into maybe the greener pastures of technology back in 2015. Co-founded my first startup, a startup called Nez. And then since I've co-founded 3 startups, have a couple of exits under my wing, a couple of failures, of course, which is the natural startup progression. I think really kind of, poignantly, each one of those ventures or experiences has actually been in a slightly different sector. So I started sort of in B2C marketplaces and retail, moved across into a sort of mission-based D&I initiative. And ultimately, my last startup before Edgify, which I'll get to second, was called Volta, which is still very much operational. I'm still on the board. I stepped down as a co-founder and COO back in January of last year, but that was in the sort of mixed reality, metaverse, AI sphere. What we are doing is helping musicians create interactive visuals. So if you've seen the Tale of Us or Eric Prydz or Deadmau5 or Bjork or Coldplay type concerts, the technology providing the visuals is often our software.
Oh, cool.
So I guess that journey has given me that desire to get into deeper and deeper technologies and to really push the needle and push the boundaries of what's possible, which culminated in me joining Edgify. It's probably a good chance to maybe introduce what Edgify is up to. And on that basis, it's Edgify.ai. So AI, of course, being the buzzword of the last couple of years. I think really to frame what we're trying to do at Edgify in the easiest possible way without getting too in the weeds is ultimately in sort of 2018, the birth of, or at least production-ready large language models, the same sort of tech that powers, or AI tech that powers platforms like ChatGPT and chatbots and sort of various kind of text image or text recognition systems was gaining prevalence. Mm-hmm. And with those systems, these LLM models, they work incredibly well in a digital environment. So if you're on your laptop or in somewhere with great bandwidth, they work brilliantly because how they work ultimately is they'll feed a lot of data up to a cloud or some training environment. They will process that data, create a repo, a model, an AI model itself, and then consumers or businesses or whatever can query that information and prompt it and generate new information. Mm-hmm. However, when you start to look at LLMs or those types of ways of cloud training or data center based training in the real world, the physical world, I mean brick and mortar environments, it starts to break down. And the key reason for it is ultimately data. So the first one being typically in sort of the physical space, there's a whole raft of enterprise policies or SME policies. Companies, which we serve, do not like giving away their data, especially customer data and mixing it with other customer data in some cloud somewhere else. It's a policy move. But let's say these companies were okay with mixing their data. The next hurdle you then have with data itself is the regulatory framework. If you're trying to do AI, anything camera-based or machine learning or process-based within the physical realm, you're going to cross regulations like GDPR, the AI Act in Europe, the California Act in the States, which makes it very, very, very difficult to even do this. Now, let's say you lived in a utopian, dystopian world and regulation didn't exist and companies were all gravy with mixing their data up. Well, the third and biggest problem is cost and compute power. Yeah. Ultimately, if you look to the sort of the offline space where you don't have great bandwidth, a company like Walmart will produce a zettabyte of data every single year, which would take 43 years to upload to the cloud. It would cost you $10 million in bandwidth fees and probably another $20 to $30 million in training fees. And that takes 43 years to get there in the first place. So by the time you've done all that work, spent all of that money, the AI model is redundant. So the current way of AI just doesn't work in the physical world, like retail, medical, aviation, logistics. So that was the problem set that Edgify first started with. The problem set was, how do we leverage machine vision or AI training in the physical world where there are a number of positive applications for society that need to be built? So what Edgify set out to do was to build a system called federated learning, but on the edge. So the edge in Edgify. And what's that really mean? So what it means is we have found a way, and we've pioneered a way, which is entirely proprietary, where we are able to integrate our AI agent into local hardware. So our first use case and our first market has been retail, specifically grocery retail. Okay. The big problem within grocery retail is currently, the consumer experience. So if you're a consumer and you go into somewhere like Sainsbury's, who's a client of ours, where we have a nationwide rollout, if you went to Sainsbury's, you might purchase some fruit and vegetables, have to go to a scale, weigh the fruit and veg, get a sticker, go to a self-checkout, put it in there, hope that the alarm doesn't go off and a staff attendant comes over. It's a horrible, clunky experience. It's ultimately very slow and very off-putting. Yeah. The bigger problem there is actually loss. And the amount of loss that retailers are now losing globally. It's a $240 billion problem, and it's growing 30% year on year. Tesco, for example, in the UK loses £300 million sterling per year now. Cost of living crises, inflation, general civil unrest, given unfortunate political events, has just meant that people are having to steal more, whether malicious or otherwise. Interestingly, by the way, as a side caveat, milk is one of the most common items stolen. Actually, in that case, it's not stolen.
Why?
Crazy, right? But that's
like chewing gum or something, not milk.
Well, it's because the condensation covers the barcode, so people think they've scanned the milk, but in reality, they haven't.
Oh my gosh!
It's a very mundane problem, but the problem there is retailers then don't know how much milk they have in inventory, so they overorder milk. And I can bet you every single time you go to a supermarket, what do you always see plenty of? Milk. For that very reason. We have a quote, for example, from a partner of ours in the States that they said they sold twice as many bananas last year as they had in stock. So it's not just a loss problem, actually, how much raw profit they're losing. It's all these downstream problems into inventory management, supply chain management, and furthermore.
Have you been to like Asda recently in self-checkout where you put the fruit in there and it actually tells you, it will know what you've put on the scales?
Correct. That's the tech.
That's the tech. That's your tech.
Exactly. Oh. Not quite. But stay tuned. There's some pilots and things moving around there, so stay tuned on that side. But that is exactly the tech. So yes, back to the solution. So we found a way to integrate our AI agent, so Edgify, into whatever local hardware exists in that environment. So in Sainsbury's, who's a client, for example, of ours, we integrate our AI agent into the self-service scales. So the scale itself has a camera. What that means is, so we integrate into the self-service scales, the self-checkouts, the cashier point of sale systems. And what we do is ultimately then we use the compute power from those local pieces of hardware. Fundamentally, this is called federated learning. And what that basically means is that the data never has to leave that store. It's all being trained locally. It's all being run on the same network, their private network. Customer data never leaves that store. And crucially, it means that the system itself is learning from real customer behaviors. So that's ultimately the solution set, and the implications of such means that we don't need to add any additional servers in a store. There's some players that agree with the thesis you can't send data out. Well, all players agree with the thesis you can't send data out of an environment and put it to the cloud. So some people have tried to solve the problem by physically installing a $50,000 server in every single store or hospital or whatever they're trying to work in. That doesn't work for companies. It's too expensive. It's a company like Target with 10,000 stores globally, you'd be talking 500 million in servers, which just does not scale. So we found a way to make scalable computer vision that has cross applications.
Wow. Okay, that's pretty interesting. Okay, so now I know where your technology is in the supermarkets I go to. Basically, that self-checkout in Asda. So that's the one of your clients as well then?
I can't comment there.
Okay, fine.
There's ND in place, but I can comment on Sainsbury's.
All right.
Look, interesting. I think a good proof point here is Whole Foods is a client of ours. Whole Foods, which is owned by Amazon. So
Yeah.
Amazon themselves, who have a very robust AI model and training model, agree that Edgify is the way forward when it comes to local, physical, real-world applications of AI.
Amazing. And then I remember like when we spoke earlier on, you mentioned something about sort of like energy efficient chips. What is that exactly? And then why do you sort of feel that is like crucial into the world of AI that we're in at the moment?
It's a great question. I think, that comes into two parts. I think the first way to address that question is, why do we need energy efficient chips, right? Why is that even a question on people's minds? And I think that really goes to what's on the tips of everyone's tongues, which is compute being the new oil of the 21st century. The analogy is perhaps a little stretched. It might have come from historical precedents, like the transition from steam to oil-powered engines was a pivotal moment. So people argue that the shift to advanced compute power is reshaping our world, driving innovation, so on and so forth. But really the problem here is that the amount of compute that we require in order to run these AI models, we actually currently, as things stand, we need an order of magnitude of about 3 times more electricity to run the existing systems we have in place.
Right.
Now, the demand for compute is only increasing with each, despite the fact that we are finding more effective, more efficient, and cheaper ways to train AI models. The fact is that data is only increasing. The amount of data that's being produced is increasing. I think it's 20% year on year at current rates. We've got advances in compute itself. So quantum computing, for example, neuromorphic chips, and other technologies that are set to further revolutionize things. We're plugging into more sectors. So whereas previously it might have been, AI was precluded to the chat GPTs of the world and other sort of pieces. Now what we're seeing in terms of compute being the new oil is it's actually a strategic and competitive advantage. Companies and nations that control significant compute resources will hold that strategic advantage in the 21st century. Satya Nadella, CEO of Microsoft, states the ability to harness and deploy compute power effectively will define the leaders of tomorrow's digital economy. It really is. The more compute you have, the more effective you can run AI models. And if you can run more effective AI models, you can achieve more positive outcomes. And whatever that outcome could be is dependent upon the sector. Now, to address your question, however, why therefore do we need energy efficient chips? Well, it's again, if we say compute power is a fundamental resource akin to oil in the 20th century, we need energy efficient chips because there will be a time that we run out of compute power otherwise. And the other problem with this is that China itself actually has the dearth of these chips themselves. So we want to control their strategic advantage when it comes to economic might. I think another thing really to address here is, let's actually take a step back here and define it. We've got the CEO of AMD, for example, Lisa Su, that describes at least an energy efficient chip as a chips that optimize performance per watt, ensuring that we get the maximum computational power with minimal energy consumption. So the other implication here is not just the fact that we need chips that can produce more compute on the same level of energy, but the other problem here is the environmental impact of AI technologies. Compute compute requires electricity. And in a world in which we're still burning coal, unfortunately, still burning oil, the increase in compute actually has a horribly negative knock-on effect when it comes to the environmental impact and sustainability impact of said AI. And if we need to move to a world where, if we are moving rather to a world of increased compute demands, quantum compute, and increased data requirements, at the same time where we've got a humongous headwind of global warming, the necessity for these energy efficient chips is fundamental to the future of humanity, in my opinion.
No, absolutely. Yeah. So, and then in terms of like, is there any examples that you can provide in terms of, and I don't know if you've already mentioned this already, but like, how are some of the chips already being used in our everyday lives in terms of the AI applications?
Yeah, I mean they're prevalent. They really are prevalent. They're already on the march, and Morse's law, which is technology's output will double every 2 years, is only actually slightly increasing, if anything, quite interestingly. And we're seeing these sort of energy efficient chips making their headway into a plethora of different sectors. Just to call out a few: smartphones and mobile devices. We already have AI embedded chips within the Apple A series chips and iPhones, which are designed to handle complex AI tasks like facial recognition, natural language processing, and now augmented reality, whilst balancing battery efficiency. I think there's a quote from Tim Cook, if I'm not mistaken, which actually he kind of says ad verbatim: our chips enable powerful AI experiences without compromising battery life. And we've just now seen, of course, the Apple Intelligence announcement. It's a little bit remains left to see what actually comes through, given it was the first sort of Apple announcement where they didn't actually launch a product, and it's more the future to come, which I find is quite an interesting paradigm what we're in. But I think stay tuned for that space. I think another example that is, that really just demonstrates the prevalence is autonomous vehicles and even semi-autonomous vehicles. Energy efficient chips are crucial for processing data, sensors, and cameras in real time. Like cars, autonomous vehicles have an incredible amount of data consumption.
Yeah, like Waymo, all those companies.
Exactly. And ultimately, it means that currently, most of these autonomous vehicle manufacturers are probably only processing between 1% to 2% of the data from these sensors that are connected. You can kind of think of them a little bit like what we heard 5 years ago of the, what was it called again? IoT, the Internet of Things, right? Where everything was sort of connected.
That used to be the buzzword, didn't it? It does come up now and then, not so much now though.
Exactly. I mean, ultimately, it's kind of, we feel a little bit at Edgify that our federated learning model is a bit like an IoT, because we just use different hardware, embed our agent, borrow a little bit of the CPU and GPU, and off we go. But, back to the sort of autonomous vehicles, it's a place where NVIDIA, which is, arguably the most important company, at least in chip manufacturing currently to date. They certainly are, and probably one of the most prevalent companies on earth. I think they were number one.
Ahead of Microsoft now, if you saw the announcement. Yeah,
exactly. They were briefly number one in the world on market cap, if I'm not mistaken. But they have their own what's called the NVIDIA Drive platform, which is powered by their energy efficient GPUs. And the crucial, the importance there is autonomous vehicles need to be able to make a decision in split seconds, like absolute microseconds. And we've all heard of the challenging sort of philosophical debates when it comes to what options you take between, say, a child or a grown adult, and so on and so forth. So the importance here of is highly accurate and highly high throughput sort of mechanisms is so power. I mean, Elon, for example, it's core to his AGM. It's core in a number of his shareholder announcements. It's a lot of big reason why I believe personally that Elon was an initial investor in the OpenAI project.
Yeah.
Because efficient compute power is the fundamental key to making autonomous vehicles practical, reliable, and safe.
Yeah. Super cool. I mean, the thing is, what are your thoughts? Just talking about the autonomous vehicles, I'm just curious about your opinion. So obviously, I've rode on a Waymo; it is pretty cool. But then Cruise also used to do it, and then obviously, well, they still do, but obviously they had quite a lot of faults on their cars, didn't they?
They did. I mean, I think, as it stands, it feels a little bit utopian for me. And look, I'm biased. As I mentioned, I used to be a racing driver, a little bit of a petrol head back in my days.
Yeah.
I think.
I mean, they don't go fast. Let's put it that way.
And I can certainly live with that, and the luxury of being able to, let's say, do some work whilst your car is driving you to the office or whatever it is. That all seems fantastic and seems like a huge gain in productivity. But I think so long as you have human drivers around, I don't think it's possible. The unreliability of different humans and human decisions means that I think for me, you need either 100% autonomous vehicles or none. I don't think there really is a middle ground, and we've seen all sorts of nasty failures happen along the way. And again, what happens when a child steps out into the road, or a grown adult with a walking stick? It's these kind of things that I don't believe we are close enough yet to having the systems in place that can accurately defend against these measures. So for me, I think a lot more research is needed, a lot more infrastructure and development. I like what I'm seeing in some of the parts of California where it's kind of moving into sort of a regulated kind of totalitarian sort of view, but it does feel a bit restricted. It does feel like you're bringing in a technology and taking away liberty and flexibility in the process, which personally I've got some gripes with.
Yeah, no, that totally makes sense. I completely agree with you there. I mean, I got into one of them. It wasn't that scary, but it was going at like 20 miles per hour. So
I get nervous with when if I drive a sort of a rental car that has the semi-autonomous mode where it's kind of cruise control and the steering wheel, because I can feel it. As an ex-racing driver, I can feel what it's doing. I feel the car. It feels intuitive to me, and I can feel what it's doing. And it doesn't feel right. It doesn't feel like how I know to drive, which inherently makes me feel like, is everything working? Because it's sort of like a plane, right? When you get on a plane, you assume the safety of that plane has been verified. You don't check. You don't ask for records.
No, you don't.
However, these cars are pretty nascent, and they don't go through the same regulatory testing when they're on the road. They certainly do in factories, and they certainly do post release. But on the road, that's where externalities start to appear, unfortunately, and extreme weather events and other things. That it's the unpredictability, I think, are just too challenging there.
No, I totally agree with you. Just going back to sort of your business, so Edgify. So obviously you're focusing on systems that doesn't really require additional compute. How does that actually really work? Like, if you were just to kind of explain it to like an average person on the street, like how does that really work?
Absolutely. So I think let's maybe the best way to kind of demonstrate it is through a practical example, as opposed to going through the sort of the nitty gritty. So if what we do ultimately in the grocery retail space, and I must stress that Edgify itself is a multi-sector proposition. We're running projects and POCs in medicine, in manufacturing, logistics, and so on and so forth. But I think the retail use case is just an easier one to describe to people, because everyone goes to a supermarket at some point in their life. Everyone's experienced the retail offering. So how does it work? Ultimately, we install let me take one step back. We often will work with the hardware manufacturers. So we form partnerships with the hardware vendors that already are in these stores. From self-checkouts to self-service scales to CCTV cameras, whatever it is. We'll form a partnership with them. We'll embed our technology, our agent, as it's called, into their hardware. And all that really is a simple API contained in a Docker environment, which pings back to our mainframe. So what then happens is when we go to a store, let's say we're launching in Sainsbury's, the first sort of between 4 to 6 weeks of a pilot, we will pilot because that's where we establish business KPIs. So in the context of Sainsbury's, it was more around can you decrease staff time spent with customers? Can you increase customer throughput, so how quickly customers can get in and out the door? Because customers are not like dwelling in a supermarket. It's not like a coffee shop where dwell time is great. It's kind of the opposite. But fundamentally, can you find and deter loss? So what we do then is establish kind of the baseline. What business KPIs do we need to reach in order to satisfy the organization? And then for the first 4 to 6 weeks of a pilot, nothing fundamentally is different in that environment. So if I'm a customer and I have a banana and I go to my self-service scale, I will do my normal thing. I'll weigh the banana. I'll type in, this is a banana. But crucially, the camera's watching. The camera's learning every time a customer types in, "This is a banana," it goes, "Oh, that's a banana." We then have in our dashboard the technical KPIs. So accuracy levels, prediction rates, what we call as an unknown, where it doesn't know what that thing is, or mistakes, where customers try and override things. And once we hit a certain threshold, which is generally around the 85 to 90% accuracy level, we do average actually now 98, 99% accuracy across our retailers.
Oh, wow, that's pretty good.
I'll get to this in a second, how it gets better and better, which is the exciting thing. So ultimately, once we hit that threshold, then the user interface of that screen, whatever device it is, will change. And no longer do you need to type in what that object is. It will just say, banana. And if you try and trick it and you do something clever like, let's say, the classic one is scan a packet of chewing gum and you've got an expensive AirPods on top, it will see those are AirPods, that's a chewing gum, and the screen might flash up depending on the retailer who chooses it saying, "Are you sure you just scanned a chewing gum? We see this." Or something to that effect. Or it might send an alert to a staff attendant letting them know something's happened here. It's always, the customer experience is always primary for the retailers. But what we try and do is to try and deter loss at the screen. Because unfortunately in America, 43 individuals were shot last year. Security officers were shot for trying to stop shoplifters. It's crazy.
Wow.
So if we can let the computer do the work and deter the violence and deter the loss, that's a great step forward.
Yeah.
Exactly. So once we then hit a certain level of accuracy, the pilot's usually in a contained number of stores. Then ultimately what's happened is the system is continuously learning. And this is a huge advantage of edge-based training. And that edge-based training basically means an edge device is anything that's not like a server, for example. So a mobile phone, a self-checkout, camera, whatever it is. The customers are training it on the edge. And then the inference is the next step, which is kind of the prediction level. That's also on the edge. So as far as we're concerned, and each of our investors agree, and we've gone through multiple rounds of due diligence, we're still currently the only company on earth that does distributed learning on the edge with edge-based training and inference. And now what does that mean in terms of removing the tech and actually getting into tangible benefits? It means it's constantly learning, getting better, getting smarter, and learning from real customer data. The advantage there is if a retailer launches a new product, it's Halloween and a pumpkin comes out, it will learn very, very quickly what a pumpkin is. If one store all of a sudden it's raining or it's snowing in a particular store, the system is adaptable. It's seen it before, it's seen those learnings, and colors, hues, lighting make a huge difference to machine learning models or machine vision models. So in this way, each store has its own independent learnings. At the end of the day, each store shares its data through something called a collaborator, meaning each store independently gets smarter, smarter, and smarter. So our accuracy scores can increase and increase over time. So mathematically, we can't be beaten. The truth is, the first couple of weeks of a project, if there are cloud-based solutions that have trained expensive models in the cloud or whatnot, they might have a quicker, start to market, but they do not benefit from greater accuracy. In fact, they have data drift. The models get weaker and weaker. Accuracy scores go down, and you have to keep spending tons of money getting all this data back up to the cloud, retraining it, and sending it back down again.
Wow.
So that's a little bit of the trying to simplify some of the.
That's super insightful. Obviously, as we're in an energy efficiency mode in terms of our world right now. We're trying to kind of save as much energy as possible. So I'm sure this is a question that probably comes up with some of your prospect clients. So how do you guys, despite the technology you've got, the fact that it is using a lot of energy, how do you make sure that you're being as efficient as possible?
I think primarily it's the fact that we aren't using big servers, which are highly energy intensive. We're not transferring the data from anywhere. Doesn't leave the store. In fact, the learnings I mentioned before are simply learnings. It's a text file ultimately that gets shared between different stores. There's no images, videos, or anything like that. That's all where a lot of the computational power and bandwidth, right, which will use electricity, comes from. So we bypass the need of servers, we bypass the need of bandwidth, cloud hosting fees, and the cloud ultimately is again another big server or a data center, which is sort of branded. So by bypassing all of that, what we do is ultimately we borrow a little bit of the computational power of these hardware devices that we integrate to locally. So in other words, electricity remains stable going into the actual device, We borrow whatever we can get our hands on, depending on how much actual computational power the machine needs for what it's actually doing. And in that way, there's no extra strain on the system. So you could call us to a certain degree net zero in terms of the system, in terms of the impact.
Amazing. Okay. Really cool. Well, I mean, what's next for you guys then? So have you got any sort of exciting projects, any developments and sort of the horizon that you're able to share? I know there was quite a few things I asked you and you weren't able to share. Is there anything you can share?
What can I share? So I mean, there's we tailwinds are certainly our favor. We've grown 10x in ARR in the last year. We are growing 10 stores a week currently. I think ultimately we set our sights on being in retail perhaps for a year and a half. What we've learned is ultimately retail is a fantastic space that we love. We're able to go deeper and deeper. So a lot of the use cases I described to you were front of house solutions, self-service sales, self-checkouts, cashiers, so manned points of sales. What we've seen is there's a plethora of issues in the back end too. Waste management, for example, clients ultimately, retailers rather, will try and distribute their food to food banks. They'll try and use a number of different.
Messaging, aren't they?
Yeah, exactly. Like so, Olio, for example, I was a former CRO there, which exactly is trying to solve food waste at scale. So they'll try and distribute as much as they can, but ultimately, there's still not enough volunteers in the world to distribute all of it. So unfortunately, food has to go to landfill. The way retailers currently do it is they tip it in a bin, and that's that.
Oh, really?
But the issue there exactly is I mean, there's so many issues, but
Yeah.
from let's call it from an inventory perspective, they've got no idea what they've thrown away, which means they're now over ordering. Overstocking is a huge then sustainability impact because now they're overstocking things and having to throw away more items because they don't know what they threw away in the first place. So before they know, they're throwing away 2x, 3x, 4x, 5x, and so on and so forth. Again, simply by having a camera detecting which objects are going in the bin, you solve that problem. So waste management is certainly a very, very, very interesting space for us and something that we love from a mission perspective. There's all sorts of other applications within retail. Ultimately, our mission is ultimately to cover a store's entry and exit points. So anywhere there's an entry and exit point, there's a chance of failure, there's a chance of an error rate, and that's where we are playing currently. Moving ahead, I can maybe talk through a few use cases. I can't maybe share some client names, but I can certainly share some use cases. We're very interested in medical and medicine. The first one being in X-rays, X-ray machines. Ultimately, they have a camera. They know if your bone is broken or not, but you still need a doctor for the verification process. And unfortunately, if a bone is incorrectly diagnosed, the knock-on effects can be humongous.
Yeah.
So ultimately, we're leveraging Edgify in the same way. We love what we call as human-in-the-loop type of scenarios, where there is a human. We're not trying to remove humans in the process. It's a case where how can we enable them? So if I'm a doctor and I've got an X-ray machine, can the AI help me make a more accurate prediction as to or assessment or prognosis to my patient, such that I don't then have a lawsuit, or the insurers come back to us, or the hospital has to lose a lot of money. And ultimately, it means faster diagnoses, better outcomes, better patient prognosis. So medical, was a use case that we're POCing in. And I think another one to share is manufacturing, production lines. You still have humans that are spotting production lines, looking at them quite physically. And if there's a defect, they will sound a bell. The production line stops. They'll try and figure out where the defects happen from, and off they go. Every second, I believe that, for example, Toyota's production line is down. I think they lose, please don't quote me on this in terms of the podcast, I think their number from the lean startup at least was 70 million per second. They was to turn it on. So you're talking humongous numbers in operational gains, something that seems quite simple on the surface. I think the very last one I'll mention, we haven't yet POC'd, but it's a personal one, is aviation. 5 individuals going around a plane to see are the tires got enough pressure, does the wings look intact, and so on and so forth. To me, just feels not like a
you do need
application. I'd love to see our technology play in aviation. Yeah, and deliver more efficient outcomes and safer flights.
Yeah, exactly. Well, last but not least, before I let you go, so very broad question, but what do you see as sort of the future of AI, and especially maybe around computational power and driving innovation as well?
Very expansive last question. I love it. Let me take some pause to give my viewpoint. So, future AI and the role of computational power innovation. I mean, I think to kind of to lay the ground running, I think what we're seeing now is just the very beginning. If you look at Gartner's sort of growth curve, we've sort of moved just beyond the hype cycle, but we still have, AI has not yet been fully deployed in a number of practical applications. There's still a lot of regulatory work to overcome, which I'll touch on actually in a second. So there's still a lot of room for these models to get smarter and smarter. So I think, we will see exponential growth. We will see ubiquity. I mean, we're already starting to feel ubiquity as it is, but I mean ubiquity across all sectors. As Sundar Pichai notes, AI is becoming integral to our life's electricity, transforming every industry it touches. So the role of computational power, again, going back to the start, in enabling this transformation really can't be overstated. I think what other things we'll see is as mentioned, is advancements in hardware. We're going to have to, through quantum computing and neuromorphic chips. Ultimately, we're super excited by all of this because we're agnostic. We see these technologies coming through, and ultimately we see ourselves as a hedge to the incoming chip wars, the incoming battles, economic battles we're seeing, let's say, US and China, where the chips are currently quite heavily overweight in Taiwan, which there is some political sensitivities to right now. So I think we'll have to see advancements in hardware. And then I think I'll have to push this forward because it's our mission, edge AI and decentralization. Just as we saw decentralization that came through with currency, right? The move from fiat money into cryptocurrencies like Bitcoin. I think it's a very similar shift that we are pushing, and a number of others are pioneering with edge-based systems. Processing data locally on devices reduces latency, makes things quicker. As mentioned before, it enhances privacy because the data never leaves the store, and the improved energy efficiency. So I think that is a trend that's really going to push through. I do think the one I might say though, just to kind of to give a little more dose of realism, and to kind of to put this in the context that all of this exciting research deserves, which is AGI, if we start to move to the next layer of what we might see, so artificial general intelligence.
Oh, right. Okay. I haven't heard that often.
Yeah. It's personally, I've always found it somewhat a little terrifying. I remember watching, I think it was Terminator 3 when I was a child, which is, naturally very AGI focused. And I remember seeing, I think it's the third one, there's the AGI controls all the nuclear bombs and it's the end of humanity and so on and so forth. And I remember I cried in that movie more than any other movie. And it stayed, I think, as a perpetual fear in the back of my mind, that felt like it could be a potential unfortunate path that we might face in a century or whatnot to come. I think it's actually a key driver why I wanted to be a part of the AI world in order to help stop some of these potential existential threats. Now, at this exact point, when we start talking around AGI, which, let's be clear here, that is Sam Altman's mission at OpenAI. He does not want to build ChatGPT. ChatGPT is a precursor to AGI. The second he was fired from OpenAI, the first thing he was excited by, despite it being tumultuous week, was, cool, I can now focus entirely on my AGI research.
Yeah.
But that with itself comes with a plethora of risks. There is a lot of ethics and responsible AI requirements in place. We need to safeguard privacy. The responsible development of AI really is critical to future success, which is what the DeepMind sort of theorem. And I think as things stand, we do need some form of regulation. That is something
Everyone talks about it so much.
Exactly, and it's because of how these risks materialize. Now, when it comes to regulation, I currently think the way in which, especially the states, are introducing regs on AI is counterproductive. It's very heavy in oversight, and ultimately the plan is to almost review individual source codes and how their parameters are shaped on their AI models, which, even if you're the smartest AI professor on earth, if you set a framework now or a regulatory framework now, it will be redundant in 12 months. The tempo these models are moving at, you can't keep up. So a regulatory framework to me doesn't seem like the right response, or like regulatory capex, which you might have in like utility space. But an agency-like model feels more appropriate. And where I lean to an agency is almost like nuclear. if you have the ability to make a nuclear bomb, you are then scrutinized as such that you have the ability to make a nuclear bomb. And I think the agency-like approach should be an approach we use in AI. Do you have AI that is sufficiently capable of doing something harmful? If so, it needs to be under agency control and agency scrutiny, but it doesn't need to have source code mandates, because what it needs is a two-way conversation and a two-way oversight rather than a totalitarian sort of regime. Because I think the problem there is, with too much regulation, it will stifle. It will stifle the fantastic benefits that AI can realize, and it will fundamentally make the Western world anti-competitive to the Eastern world, who are pretty liberal right now when it comes to their AI regulatory policies. And in fact, they know they're slightly behind, so they're aggressively pushing ahead.
Amazing. Yeah, well, thank you so much, Mitchell. It's been super, super insightful. Thanks so much for joining, and catch you later.
Thank you so much, Melica. It was lovely to be on as well.
Yeah, thank you.